Welcome to Linux Actuator Academy video series for industrial actuators. I'm Hunter, and today we're going to talk about an I/O actuator's diagnostics features, one of several options configurable within the Actuator Connect configurator for Linux I/O interface. Occasionally, things stop working and leave you with the task of identifying the root cause. Diagnostics can help you avoid unnecessary downtime in your application and guide you through the troubleshooting. Linac understands the importance of uptime, and hence an inoperative actuator must be fixed or replaced as fast as possible. Linac's developed a 3-step guide that explains the most common root cause of problems and what you can do to fix them. It considers LED status, error codes, and our supporting PC configurator tool, Actuator Connect. Let's go through the diagnostics features now. Actuator troubleshooting shouldn't be complex. All I/O actuators come with a transparent connector with an integrated LED for fast diagnostics by simple visual inspection. This can be enabled as a software feature in the diagnostics menu in Actuator Connect. The LED can show different colors depending on the actuator's state and can be used to quickly determine whether the actuator is running as intended or shows a failure that needs to be looked at more closely. If the LED doesn't light up, try checking the power cable and power supply for improper connections or damage. In addition to creating a visual indication of the current status, it can also be used to see what actuator you're paired to via Bluetooth on your PC. When the actuator is fully operational, the LED will be green. If the color of the LED changes, it might indicate a system malfunction. We'll look at some of the external errors and how to fix them later in this video, but for now you can see that the LED indicates that our actuator is up and running great. For applications where downtime is not an option, Linac offers error codes as a digital output for easy troubleshooting. You can set up a digital output that every 10 seconds relays an error code. The actuator will send a number of pulses to your controller depending on the error type, following the patterns in the table shown here. This will save you time when you can easily troubleshoot the system and get remedies to solve the problem quickly, which otherwise might have ended up in unnecessary replacements. Error codes take up one of the digital outputs, meaning that you can still use the other for position feedback or in-stop signals. If the first 2 steps don't solve the issue, connect your actuator via Bluetooth or cable to Actuator Connect and select the Current Status tab for remedies to solve the potential issue. You can always find the most up-to-date troubleshooting information at linac.com. If the actuator reports a fault, then you'll be able to immediately identify the exact fault that's triggered the stop. In the Current Status tab, the actuator can also estimate its remaining useful life by utilizing an internal algorithm. You can use this feature to determine if the actuator should be replaced soon and avoid unnecessary downtime in your application. Directly in Actuator Connect, you can also view an error log. In the error log tab, you get an overview of the last 5 errors the actuator has encountered, as well as the number of times in a row these errors have occurred. This is documented with a timestamp that can be compared with the total running time of the actuator. This data can be used to help identify patterns that might help find the source of an error that's recurring. Linac also distinguishes between internal and external errors. If the actuator has detected an internal error and has stopped, try to repower the system or initialize the actuator. I'll show you later how to do this. If the internal error cannot be solved, please contact your local Linac office for further assistance. For external errors, you'll be given different remedies to solve a potential issue. An example could be a temperature error where the actuator has detected a high temperature and has been stopped. In this table, you can see a list of all the error states that the actuator can register, as well as the LED color for that state. Here, I have an actuator that has lost track of its position, and you can see that the LED light is red. To solve this, all that's needed is to perform an initialization. I'll start by running the actuator inwards past that 35 to 70 millimeter zone. I'll stop it just before the end, and we're going to run it out past that 0 point zone of 35 to 70 millimeters. And when we're past it, the actuator will initialize and the LED will turn green. Now the LED is green and we're back and initialized, and the actuator knows its position. In general, it's recommended that the actuator is initialized on a regular basis to ensure accurate positioning. This process can also be used to solve simple problems, which may result in an error message. We hope you enjoyed this introduction to diagnostics features within Actuator Connect, and that you can use this knowledge to help avoid unnecessary downtime in your application. If you have any questions about troubleshooting or diagnostics, feel free to contact your local INEC office. Thanks for watching.